Good day, everyone. Welcome to Basic Science and Technology class, and we'll be focusing on science today. And the topic we want to look at in today's Basic Science and Technology class is energy. Wow, we want to look at energy, and then we'll be learning a lot of things about energy. I am Modupe Olayinka. I am so excited to have you in today's class. I want you to pay attention. I will be learning something very wonderful today again. Now, the topic I said is energy. At the end of the class, I will want you to define energy for me, and then you'll be able to tell me the forms and the types of energy, and then the sources of energy. In today's class, we'll be mentioning the forms of energy and the types. Then, in our subsequent class, we'll be talking about the forms in detail. I'll be explaining all the forms to you in detail. But today, I'll just mention the types for you, and then I'll mention the forms of each of the type I'll be mentioning, and then I'll give you the sources of energy. Now, what is energy? You know, right from our junior class or younger classes, we've been told what energy is. Then it's just for us to refresh our memory of what energy actually is. Energy is the strength and vitality required for sustained physical and mental activity. Energy is the strength and vitality. Strength and vitality required for sustained physical or mental activity. So the strength and vitality you need to do any physical or mental work and sustain that work is what we call energy. Thus, to put simply, energy is the ability to do work. That is the definition we are used to right from our primary 1 days. We've been told that energy is the ability to do work. It still remains as that definition. It has not changed. I just give you another definition for you to equip more yourself, because you will get to know that energy is the ability to do work, fine. And it's also the strength and the vitality you require to do sustained physical and mental activity. Now, energy is how things can change or move. It's everywhere around us and takes all sorts of forms. It takes energy to cook food. It takes energy to drive to school. It takes energy to jump. It takes energy to walk. It takes energy to do a lot of things. There's nothing you do around you that does not require energy. If you don't have energy, that's why it's good for us to eat good food, so that we can have energy. Because if we don't have energy, we'll be so weak and we'll not be able to do anything. We will not have strength. So energy is required to do a lot of things around you. If you want to carry a small chair, a big chair, a bucket of water, you want to cook, you want to bathe, you want to walk, you want to sweep, anything you want to do, it requires energy. Good. Now let's go to the types of energy that we have. Look at this chart I have here. It says types of energy. In some other pictures, you may see it as forms of energy. So we have types of energy. I'll be explaining to you in the next slide, but just look at the picture clearly. We have kinetic energy here. We have potential energy here. Under kinetic energy, we have mechanical energy, thermal energy, sound energy, electrical energy, radiant energy. This radiant energy, we can also call it light energy. Now we are under potential energy. We have chemical energy, nuclear energy, gravitational energy, and elastic energy. Do you get it now? Under the types of energy, we have 2 types. Under each of the types, we have 5 forms and 6 forms. As it is in some other slides, in the next slide you see me, I'll have 6 under kinetic and 5 and 4 under potential. So we have basically 2 types of energy, 2 types. Then under each type, we have different forms and different forms. Okay, I'll have another slide again with a picture for you to have a clear understanding of what I am trying to say. This is another picture talking about forms of energy. You see the same thing, it's just for you to have a clearer understanding of what I'm trying to say. You can see this is a type of energy. This is another type of energy. Now we have kinetic energy, that's energy for movement, then potential energy, energy stored. In my next slide, I'll be explaining to you what kinetic energy means and what potential energy means. I'll be explaining those 2. It's only these forms that I will not be explaining today. I will just mention them, and then in the next class, I'll go into detail to explain to you what they mean. So, but if you look at the picture I have here very well, you can see I've given you a bullet point just for you to have a picture or an overview of what I am trying to say. Look at thermal energy under kinetic energy. It talks about energy of moving particles. That's it. Then we have mechanical engine energy under kinetic energy. It talks about energy of objects in motion. That's mechanical engine energy. Then we talk about electrical energy. That's energy of particles moving through the wire. Electrical energy. That's why if you look at your house, you see electric wires running on the wall, in cables on the wall, just to connect your electrical appliances in the house. So electrical energy run through cables or through a wire. Then we have magnetic energy. It has to do with energy that causes push or pull. If you want to push the door, or you want to pull the door, or you want to push a car, or you want to push a wheelbarrow, whatever you need to push, apply force to push, or you need to pull it. Maybe you want to drag something to yourself, you want to drag a cat, or you want to pull a cat. Now, what you need is magnetic energy. That's why if you have a magnet. How many of you have seen a magnet before? Have you seen a magnet around? Magnet makes things, it attracts iron. When you put a coin very close to magnet, or you put spoon or fork very close to a magnet, what does it do? It attracts that magnet. It drags that magnet. It drags that object. The magnet drags that object very close to itself. So the spoon will come closer to the magnet and attracts it. If it's a spoon or it's a fork or coin, anything that is iron or steel, metal, the moment it comes close to a magnet, it drags it. That's why magnetic energy is that energy that causes push or pull. Now we go to the second part of the picture here, which is the two types of. I told you that these two are the types. The types are just two. And under the two types, we have different form. Now we have energy, chemical energy under potential energy stored in food and fuel. Then we have elastic energy stored in objects that are stretched. That's why we have elastic rubber, or maybe a rubber band. What we have in a rubber band is elastic energy. That's why it can stretch. It can stretch. If you have a nose mask in the house, you can check that your nose mask. What is used to hold the nose mask to your ears is an elastic band. It's elastic. So when you drag the elastic, you find out that it stretches. It expands. That is what elastic energy does. Then we have nuclear energy. Nuclear energy is the energy that is stored in center of particles. That's nuclear energy. Then we have gravitational energy under potential energy. We have gravitational energy. What does it do? Energy stored in an object when it is above the Earth's surface. Yes, energy that is stored in an object that makes it to be able to go up on the Earth's surface, and then before it comes down back to the ground. That energy that allows it to go up, it's called gravitational energy. Then we have sound energy. Energy, that's forms of energy we can hear. Sound energy, that's why you will hear a car hooting. You hear the sound of the car. It's sound energy. Then we have light energy. Then a form of energy our eyes can detect. Energy that your eyes can see. That's light energy. That's why you can lit a fire, you see the light. Light energy comes even in the bulb. In your bulb, in your lantern, I don't know, maybe you have lanterns in the house again, but it's an old, we use it before. Our mommies and our daddies, we know very much about lantern. When you see the light inside the lantern, it causes heat. That's light. It's light energy. Or you use your bulb. When you see your bulb in your room, maybe you have this. If there's light now, you can look up. You see that bulb in the room. There's light inside. That's light energy. Now you can see the types of energy. There are two: kinetic and potential energy. Now under kinetic energy, we have thermal energy, mechanical energy, electrical energy, magnetic energy, sound energy, light energy. Now we come under potential energy. We have four of them: chemical energy, elastic energy, nuclear energy, and gravitational energy. I told you that kinetic energy is energy that is stored for movement, while potential energy is a stored energy. Now let's go to the types. Let me just quickly explain it in slide form for you. We have, as seen in the picture above, energy exists in many different forms, but they are classified under 2 types. I told you when I was explaining that slide. We have energy exists in different forms, but they are stored in, they are classified under 2 types. Those are the what? And the 2 types are kinetic energy and potential energy. Don't forget, each form can be converted or changed into other form. We can convert one form to another. We can convert heat energy even to another kind of energy. We can convert light energy. We can convert sound energy. We can convert mechanical energy. We can convert chemical energy. We can convert all these energies to another form of energy. Now let's go to the types, the ones we have under the types. I told you before that these explanations will be given in details in the next class, because I don't want to make the topic too much for you to understand. So I will be explaining one after the other in the next class. But for today, let's just get each one of them, what their names are and what they are. Then this is the energy which a body possesses by virtue of being in motion. When you talk about motion, what does it mean? What does motion? What does it mean? When you talk about motion, what does it talk about? Motion. Motion means what? When you walk or walking. Motion, movement. Motion talks about what? Movement. So when you are moving or doing anything that has to do with movement, what you are exhibiting, what you are using that at that time is called kinetic energy. You are using the kinetic energy to walk, to wash your clothes, to wash your plates, to move to the bus stop, to buy something, to do anything whatsoever. Energy that you do, that you are doing activity, you are doing something. That energy you are using at that time is called kinetic energy. Now we have, look at examples of them. We have thermal, mechanical, just like I showed you in the picture, sound, light, magnetic, and electrical. Don't forget I told you in the first slide that radiant energy, this one here, can also be called what? Light energy. Okay, so we have light energy, magnetic, and electrical. You can see that picture I have here. That is a picture of what? Photosynthesis. The light is coming from where? It's coming from what? Sunlight. It's coming from what? Sunlight. So we have that as what? Light energy. It's called what? Light energy. Light energy. Good. Now, I would have explained all of them for you, but I told you before, we'll be looking at that in our next class. So this light that you see here is coming from the sunlight, and it's making the flower, the plant to grow. So the energy that comes from sunlight is making the plants to grow. That's why we have photosynthesis, energy from the sunlight that makes the plant to grow. Now we have potential energy. What does it mean? It means energy possessed by a body by virtue of its position relative to others, stress within itself, electric charge, and other factors. So the body is not in movement, it's in one position. Now we have examples of chemical energy, neutral energy, gravitational energy, and elastic energy. I'll mention it again. Chemical energy, neutral energy, gravitational energy, and elastic energy. I told you, said is the energy that is possessed by the body by the virtue of the position relative to others. Now we have a picture here. That's a picture of a chemical energy. It's released by chemical reaction. You can see the light coming out of that. It's a chemical reaction, chemical energy. Now we have sources of energy. Don't forget I told you before that energy can be converted from one form to what? Another. We can convert energy from one form to another. You can see light energy can be converted to what? Chemical energy. Now we have sources of energy. We have two sources of energy. The first one is non-renewable and renewable energy. Non-renewable and renewable energy. What are the two sources of energy? Renewable energy and non-renewable energy. Say it again. Renewable energy and non-renewable energy. Good. Now let's look at the picture I have here. You can see this picture of renewable energy, and you have another picture of non-renewable energy. Hydroelectric wind, that's from fan, solar, biomass. Those are the renewable energy. Now we come here, we have pictures of windmill and other pictures of the sunlight. They are the non-renewable energy. Now what is renewable energy? renewable energy such as wind, water, solar, geothermal. They come from sources that regenerate as fast as they are consumed and are continuously available. Some, such as biofuel produced from food, crops, and other plants, are replenished. That is, you get them again every growing season. You replenish them, you get more of it. In the early part of the 20th century, renewable sources have become more popular as non-renewable sources has begun to deplete. That means as the non-renewable energy are going they are going to extinction, then the renewable sources are becoming more popular in this about 21st century. So we have solar energy. That's why we have in the houses now. A lot of people use solar energy now. They don't need to look for generator here and there, or waiting for the PSCN to bring light. They just switch over to solar energy. Good. Now we have non-renewable energy. Non-renewable energy. Okay. Non-renewable energy or resources such as fossil fuel and nuclear material are removed from the earth and can be depleted. They are removed from the earth and they can go into extinction. Now, in conclusion, we have learned that energy exists in many forms. You have learned that. You can see we have two types of energy, which is what? And the other one. So under each one, we have different types. Under potential, so we should mention some of them under potential. Okay. Then under kinetic, can you mention one or two under kinetic? Okay, that's why I say energy exists in many forms. Then energy can be moved from one place, one object to another. You can move from one object to another. Energy can move from any object to another. Then energy can be changed from one form to another. I told you before that we can change any form of energy, from light to chemical, from chemical to mechanical, from sound to light. We can change energy from one form to another. Then energy cannot be created or destroyed. You cannot create or destroy energy. It's not something you can visibly see or destroy. You cannot create it and you cannot destroy it. I hope you have been able to learn a lot from today's class. You have learned so much, I believe so. So let me find out if you have been able to learn one or two things. The question I want to ask you now is, name 9 forms of energy. Don't bother me if it's under potential or kinetic. Don't worry. Just tell me 9 forms of energy. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Good. You're able to mention every one of them. If you couldn't get to the 9th one, that means you should go back to your slide and study very well. And if you go to 9, give yourself a very good round of applause. Now, which of them are forms of potential energy? Which of them are, all those ones you have mentioned, which one? Just tell me one or two that is under potential energy. Okay. Right, good. Now, what does potential energy means? Energy in what? In motion. Good. Thank you so much for listening. I want to say thank you very much because I know you have learned a lot. So take care of yourself and be a good boy and a good girl. Bye.